This episode was translated from a German interview with AI.
We've been processing iron powder for decades, and now copper powder is coming into production, so it's a big step for, let's say, our tool making, quality assurance, production planning, and of course our sales team. In this case, a we really means us, because this isn't something that can be done by a small team or just two people. The entire site is behind it, so that we can then bring such components into serial production.
Welcome to the new episode of Miba Inside, Miba's tech podcast for all Miba colleagues and anyone who is enthusiastic about technologies for a cleaner planet. Here we talk about what you usually don't see: the technology inside engines, trains, ships, wind turbines, hydroelectric power plants, power grids, and much more. Our experts from Miba explain how our components help make our customers' products and applications safer, more reliable, and more energy efficient. They also show why we are among the world leaders in many of these specialist areas. Today's episode is about how pressed and sintered metal powder makes charging electric cars really fast. My guests today are Manuel Pohn, R&D Team Leader for these copper parts and this production unit, and Robert Hellein, Materials Expert and Innovation Manager. Welcome. It's great to have you here.
Hello.
Hello.
Hello, everyone. My name is Ortrun Schandl, and I'm delighted to be your host for this podcast. At the beginning of each episode, we like to get to know our guests a little better. We'll do the same with you now. So here are a few quick questions for you. Robert and Manuel, what is your favorite sintered part?
Well, for me, it's relatively simple. Anything that shines like copper, so all the copper parts we are currently developing and producing.
And my answer has to be that since I'm responsible for all materials, it's hard for me to decide. I am a fan of all sintered parts, as long as we use metal powder.
Tell us, how long have you both been at Miba?
I've been at Miba since 2016, coming straight from university, and I'm still working in research and development. I've also been working with powders and materials since 2016, and now, for about 3 years, I've also been involved in innovation management.
So you've already celebrated your 10th anniversary.
Not quite yet, in October then.
Manuel, have you already celebrated your 10-year anniversary?
Yes, I already celebrated it last year. I had a very similar career path, doing my thesis at Miba in 2014. And yes, I actually stayed on working in various positions and for various lengths of time. And now, for 4 or 5 years, I've been intensively working with copper and aluminum materials.
So, keyword thesis, which you did at Miba. What kind of education do you have?
I studied mechanical engineering at Graz University of Technology, and as is often the case with master's programs, the semesters fly by faster than in bachelor's programs, and at some point I realized I needed to write a thesis. So I applied to Miba for the thesis where my current boss interviewed me already back then, and since then, yes, I was in. And I've been very happy there ever since.
It was similar for me. I also went to a technical university, but in Vienna, not Graz. I studied technical chemistry there and then specialized in powder metallurgy during my master's program. So I actually studied this field of powder metallurgy. I completed that, then did my PhD in the field of chemical technologies, focusing on powder metallurgical steels and hard metals. And then, yes, it just happened. In 2016, the decision had to be made between the company supervising and financing my PhD or Miba, and I chose Miba.
But we'll hear later that you don't just have to study to be very successful in your team. Let's move on to today's topic. So, basically, it's about sintering, which we'll clarify in a moment. But first, these sintered parts are small components that, as we said in the intro, are found in larger drives, gears, and so on. Where exactly do sintered parts come into my average daily life? If I say I drive to work, I have an apartment, I fly on vacation from time to time.
Well, one thing you can say for sure is that if you're driving a car to the podcast recording, there's an almost certain chance that there are Miba sintered parts in there. We are very dominant in the automotive industry with our components. To be exact, in the engines, transmissions of, in fact, all European car manufacturers.
Are there other areas of application where I might not even think that there are powder metal components from Miba in them?
Yes, in addition to automotive, there is also the so-called non-automotive business. So basically, anything that drives can be assumed to have parts from us in it somewhere.
Another example outside of automotive applications would be the industrial sector, where we manufacture parts for compressors in Brazil, for example.
We've been talking about sintered parts the whole time, so let's clarify the question. What exactly is sintering? Who will answer that? The innovation manager or the materials expert in this case?
I can do that. So we have metal powder as a raw material, as you mentioned at the beginning, which we press. In other words, you can imagine that the metal powder is poured into a mold, a top punch and a lower punch, apply pressure, and the metal powder is pressed into a component. This already has a certain strength, but to really become a metallic component, it has to undergo a thermal treatment, which you could call baking. In our case, it goes through the sintering furnace, where the compressed particles bond together to form a component. In many cases, the component is then finished.
That means you don't have to treat them afterwards.
No, there are some post-treatment steps, such as forming, calibration steps, heat treatment, meaning harden it, but everything is actually optional. There are some parts, especially our high volume ones, that are really only pressed, sintered, and then delivered to the customers. So it's a very efficient process, which is why it's used in automotive industry. Steel powder metallurgy is actually known for producing high volume components very cost effectively.
Explaining high volume, we're talking about millions of parts that we can produce with this process route, and as Robert already mentioned, it's a very complex process route, but it's very versatile and can actually produce many different components.
So as you said, sintering is similar to baking. The molds are perhaps a bit like those in a sandbox. I have different molds that I can fill with the material and press, with the difference that the sand molds are not heated to 1000 degrees. Manuel, what is the advantage of this? A sintering furnace reaches over 1000 degrees. So why do you put the already pressed metal powder through such a furnace?
Well, you can imagine it like this. If you have a gear in your car, it is naturally subjected to stress. This gear has to do something in the car, transmit power, and if we just compress the powder, then I only have a compressed component with no strength, and the sintering process ensures that the particles diffuse into each other in this case, and thus also obtain the strength they need.
Diffusing into each other means they merge together, right?
It is very interesting that everyone thinks it becomes liquid at 1120, 1130 degrees. But with most of the materials we use, nothing becomes liquid. So this diffusion process that Manuel mentioned happens in the solid phase, which means that nothing necessarily melts in our case.
But they bond with each other, right?
Exactly, through chemical processes that do not involve melting.
And can the strength be compared to that of solid metal in any way?
As a rule of thumb, it would be about 80% of the strength of solid steel. If we then follow up our forming processes, we achieve full density in the stressed component areas, and then we are equivalent.
If you want to know exactly how a sintering process works or what it looks like at our sites, you are welcome to watch the Miba videos on YouTube and subscribe to the Miba group channel and follow us. There you can see in some videos, animated or live at our locations, what a sintering furnace looks like, what the metal powder looks like before it is poured into molds, or rather, in the case of powder, pressed into molds. Let's now move on to the component of the day. Manuel, you already mentioned that we're talking about copper parts, that is, copper metal powder. These copper parts are highly conductive and are used in the charging infrastructure of electric cars. That sounds very complex. How can we imagine that a copper component that was first metal powder is then pressed and heated to a high temperature used in a charging infrastructure? And why exactly that?
It's basically relatively simple. You can imagine what used to be the gas station for combustion engines, where you filled up with diesel or gasoline. Of course, with electric cars, it's now electricity that we have to refuel. And in order to transfer the electricity as quickly and efficiently as possible from the charging station to the car's battery, you naturally need highly conductive materials, and copper is perfect for this. It is the material with the highest conductivity, both electrically and thermally, among the common materials. And yes, we thought about where we could use our components, what the advantages of our technology are, and we came across the charging station. You can imagine it like this. There is a connection between the charging station and the car, the connector that I then plug into the car, and it is precisely this connector at the front that must be able to transmit a high current density, and that is exactly where our component is located.
And copper, because it is extremely conductive compared to other metals, right?
Exactly, two advantages. First, extremely high electrical conductivity, and what Robert said earlier about strength in iron-based components applies analogously to our non-ferrous metals. This means that copper has the same material properties as solid copper, except that we have the advantage of shaping it.
Could you explain that in a little more detail? You mentioned solid copper. The strength is the same, but you have the advantage of being able to press the powder into a mold. That is actually the advantage of all metal powder components, but also of copper. What exactly can you do with it? What freedoms do you have that you don't have with solid metal?
You can imagine that current carrying components are sometimes very complex, especially in terms of geometry. It doesn't just have to be a pipe, it can also have branches or different structures. And you can imagine that if I machine such a complex component from solid material, I naturally have a lot of material waste. It's very costly. And solid copper is, let's say, not very exciting to work with.
Why?
Copper is very ductile and produces very long chips. That means that every machinist is happy when they don't have to machine too much copper. And in this step, we simply have the huge advantage that we can already reproduce the complex structure and shape in the mold and have a material utilization rate of almost 99%. That means 1% of the total material we use is the waste of the smaller machining steps. But in general, we can use the whole amount of powder to make components.
So you can get the most out of a valuable raw material?
Exactly.
At the current price of copper, it's even better than steel or iron.
Does that mean that in the future, all charging stations will have these small copper cylinders in them so that charging is really fast?
Well, in the best case scenario, yes, but you have to be a little realistic. Our components are used in high performance charging stations. You shouldn't expect to find our copper components in your wall box at home, for example. They are really intended for fast charging stations. That means if you want to charge a car in a few minutes with a really high current, that's where you'll find our components. And in the future, of course, we are not tied to the charging infrastructure or to the charging station, but we can manufacture different highly conductive complex components, and the next step will be to find and search for these in electric cars, to use them there.
That may have been lost a little earlier in the very simple explanation of how our process works with one upper, one lower punch and a mold. In reality, there are usually several punches. Very complex shapes are involved. That's what Manuel said too. For example, cooling channels. We can already implement certain shapes that otherwise require a lot of machining during processing. That's actually the big advantage.
Cooling channels in cars then?
No, cooling channels in components. Specifically for the plug, which is cooled, and that is much more efficient for us to manufacture than using exciting machining.
Robert, you are an innovation manager. How did you actually come up with this idea? Well, you're a materials expert, you're a metal powder expert, but how did you come up with the idea of trying out a new metal and a new application?
I didn't come up with it on my own. We supply most of our components to the automotive industry and have been involved in this field for several years. The entire company has been thinking strategically about how we can tap into other markets, perhaps process other materials for other applications, and from this overall strategy, we have defined a number of materials that can realistically be produced with our equipment. These included copper and aluminum, and we also looked at titanium, at least on the R&D side. Of course, customer interest also played a role, and it grew steadily. Once we knew we could process copper, we obtained a number of patents for very special processes that only Miba is capable of. That's how it all came together.
But I also heard, if I understand correctly, that as part of this development, you learned even more about the material. Is that right?
That's pretty interesting how we were developing. It wasn't all that simple. At the beginning, our team tried out some new materials and we realized, okay, there's potential here. We can actually make something out of this. And as always, the question was, what do we do with it? And at that point, luckily, a customer reached out asking for a copper component. We took that opportunity and said, all right, there seems to be market interest. Let's move in that direction. From there, we kind of worked our way forward because honestly, we didn't have any real expertise in that area. So we relied heavily on the customer's knowledge. What exactly do they need? While at the same time figuring out how we could push the technology and the material development further. It was very much a give and take with the customer. And the product I mentioned earlier actually came about in exactly that way. We got in touch with the customer almost by chance. He said he was looking for someone who could manufacture this part, and we said, well, we have a very innovative approach. And so within 10 months, from the initial contact with the customer to the start of series production, we had the part ready to go.
So this development was the result of very close cooperation with the customer. Exciting! The Austrian Miba Sinterers, as you are known within Miba, are based in Forchdorf. So Miba Sinter Austria is basically a place where Miba not only researches and develops, but, as you mentioned, also runs full-scale series production. Tell us a bit about how that works together, how a product like this actually comes to life. You already mentioned the customer side, but how does the process look at your site, and what are the advantages of having not just a development hub, but a full production facility right there as well?
Yes, coming back to the product again, as I said, we received very specific customer requirements. And of course, we also have the equipment to manufacture it in our development department. There is always a difference between making one part as a prototype and making many thousands. And precisely for this approach, where we then transfer the whole thing from individual prototypes to series production, it is of course essential to be able to draw on the know-how and technical expertise of our long-standing employees. And that's exactly how development takes place. And this means that once we know that a component will go into series production or will be manufactured in high volumes, we also draw on the know-how of our specialists, who then give us valuable tips on how to do this and how we can produce thousands of parts per day. Without their know-how, this would not be possible.
I must also say that this strategy, existed on paper. Of course, we knew we could use our equipment, but we still had to adapt something at every step of the process. And that works really well when the development team has access to the production equipment or when they can go out there and tweak things together with the colleagues on the shop floor. So it was really a big step for everyone, starting with the powder, filling, pressing, then forming. It's actually not a process step with exactly the same settings on the plant as it is with steel.
And in addition, it's also a big leap forward. We've been processing iron powder for decades and now copper powder is coming into production. So it's a big step for, let's say, our tool making, quality assurance, production planning, and of course our sales team. In this case, a we really means us, because this isn't something that can be done by a small team or just two people. The entire site is behind it, so that we can then bring such components into series production and, looking further ahead, use them globally in addition to or instead of Forchdorf.
We is the keyword that we would like to pick up on again now. Now, I would like to ask you to tell us a little bit about your team. So you already mentioned that you work closely together from where the powder arrives to the moment when the part comes out finished. Tell us a little bit about who this we is. How do you work together? And I mentioned before that it's not just university graduates who are on your team and in development. How does that work together at your company? Who do you need for such an innovation or for such a successful product?
We actually need everyone or all of them. We are very diverse, I would say. So on the development side, the core team, or I would say the headquarters, is in Forchdorf, Austria, but we have R&D at all 5 of our production sites. So we have our R&D teams there with different areas of expertise. And you already mentioned that it's just as important to have people who have studied mechanical engineering, as you might expect, as it is to have people who have trained with us, like apprentices, who then specialize and start working in development with us.
Yes, we also have, as is often the case, long-serving skilled workers who have been transferring their expertise to development over the last few years. We also have trained heat treatment experts we also need, so it's very, very diverse, and the activities are also correspondingly diverse, from when we start with powder, pressing it, to developing a process, or from measurement activities to activities in the laboratory, from microstructure analysis to strength testing. I also have to test the component characteristics, so you can imagine how diverse the range of tasks is.
It's important to note that we have always been committed to covering everything from materials testing to component testing to system testing at the Miba Sinter sites. To manage this, I actually need the entire team and all their expertise. And we have now actually acquired this expertise for copper components, just as we did in the recent past for soft magnetic components, starting with the powder and ending with testing on the system, like for example an electric motor.
Great. So that means you need the entire team, regardless of their training, everyone working together. What else is crucial for you to develop a successful product? Are there any other components that you would say are essential for successful development?
I am convinced that what is essential is simply the freedom to think outside the box. Otherwise, you wouldn't come up with the products. Or when thousands of people say it can't be done, we often don't actually know if it can be done or not, so we just do it. We usually come to the conclusion that it might not work 100%, but so far we've mostly found a way to make it work. And that's the point. Of course, Development isn't always easy and fun. That's logical. You encounter obstacles. You often find things where you say, this is reaching the technical limits. But what makes the mix and the diverse mix is that you have a lot of different approaches. And if you don't completely close yourself off to them, but pursue them to a certain point and say, okay, let's just try something that we suspect won't work, at least we'll learn something new and we'll still be able to develop such products.
These are often the supposedly stupid questions from a non-expert or from another field that make you think in a different direction. We've already discussed that we don't just have mechanical engineers and materials scientists, we've also had physicists, so we really cover a lot of different fields. The topic of AI is becoming increasingly important, as is the topic of robots, humanoid robots, so you could say that we will always need all disciplines.
Great. That sounds like your work is very varied. What do you actually enjoy most?
I have to admit, I'm not a repetitive person, so if I had to do the same thing every day, I wouldn't do it for long because I just find it boring. Thankfully, in my case, it's usually not the case that you do the same thing every day, but rather the opposite, that it's very varied, and I can handle that very well. I don't know yet what I'll be doing in 6 months' time. It will remain in the same department, that's clear, but don't know now what we are developing in the future, and that's what makes it exciting.
Yes, I agree with Manuel. It definitely remains exciting. Every day is exciting, especially for me, since I'm responsible for powder materials, which we need globally. This means working with our other locations to work on their problems. It's actually a big advantage that we have that we're represented on almost every continent. I wouldn't want to miss that.
Miba develops solutions and technologies that are designed to make its customers' products more efficient, environmentally friendly, and safer. How does this copper component contribute to that?
I would say that it's not just the copper component that contributes to that. We have already addressed the issue of sustainability and have also carried out a very extensive evaluation of the CO2 footprint of our products with one of our suppliers. We have an 80% lower product carbon footprint than conventional steel rods. There are various reasons for this, but one of the main reasons is that our raw material, iron or steel powder, is already produced from scrap. This means that our big advantage is that we start with almost zero as our starting product. We use almost 100% of our raw material to manufacture the product, so this is of course far superior to machining. This applies to copper as well as iron and steel, which is the real big advantage of powder metallurgy.
Sure, if we're now moving in the direction of e-mobility, this helps to reduce environmental pollution. And that is also a very clear requirement on the part of the owner, of course, and also our inner drive. What can we contribute to take a big step forward in this area, or to go along with it?
Thank you very much, Robert and Manuel, for this exciting interview. It was great to have you as my guests.
Thank you for having us.
Thank you. It was a pleasure.
Together, we are creating technologies for a cleaner planet. Thank you for listening. Feel free to follow this podcast on the platform of your choice. The next episode will be available on the first Tuesday of next month. Until then, take care.
This podcast is produced by